Good morning, friends. So, in the last lectures, we started fifth unit. Miss that is the fifth unit chapter is the torsion. So that's why today I am continuing the chapters. So this whole chapters that depends on the torque equations. So torque equations T equal to polar moment of inertia C theta, and this is equal to tau divided by R. So here T is the torque. T is the torque in Newton mm, polar moment of inertia and this is equal to pi by 32. So instead of the pi by 64, so this is for solid, and for hollow pi by 32, capital D raised to 4, small d raised to 4, and C is the modulus of rigidity, theta is angle of twist, this is in a radian, L is length of shaft, this is in also in mm. This is to be considered, this may be given in the meter, and tau, this is maximum shear stress, unit megapascal or Newton per mm squares. R is outer radius, and this is also in mm. So in this chapters, basic equation, this equations is the torque equation. So try to remember this equation, and these equations are known as torque equation. So measure these chapters that depends on this formula. So please note down today's first problem. A metal bar of 10 mm diameter when subjected to a pull of a pull of 23.5 kilonewton gave an elongation elongations of 0.30 mm on a gauge length of 200 mm. So this is tensile testing. In a torsion test, on the same material, a maximum shear stress of 40.71 Newton per mm squares was measured measure on a bar of 50 mm diameter. The angle of twist measured over a, the angle of twist measured over a length of 300 mm being 0.35, determine the Poisson's ratio of the material. So here first tensile test apply. So that's why by using first tensile test. So here D equal to 10 mm, P equal to 23.5 kilonewton, elongations of delta L equal to 0.30 and L equal to 200 mm. So here's by using we can calculate the Young's modulus. So stress equal to formula load divided by area. Load equal to, so this is multiplied by 1000 because this is kilonewton, so that's why multiplied by 1000, and area pi by 4 into 10 square. Stress equal to, so this is 23.55 multiplied by 1000 multiplied by 4 divided by pi divided by 100. So this is 299.84 megapascal. Now strain equal to, so we'll find out Young's modulus. What after that we'll see what happens. Strain equal to delta L by L. So delta L, and this is given 0.30 and L equal to 200 mm. Sorry, 0.30 divided by 200. So this is 0.0015. Now E equal to stress divided by strain. So stress equal to 299.84 divided by so this is equal to 893 megapascal or 1.998 into 10 to the power 5 megapascal. Now for torsion test. So for torsion test, what is given? Shear stress equal to tau equal to 40.71 Newton per mm square. D equal to 50 mm. Angle of twist theta equal to 0.35 radian. Length equal to 300 mm. So here by using relations tau divided by r equal to c theta divided by L. So tau equal to 40.71, r equal to, so this 50 means this is 25, 0.35 length equal to, this is 300 mm. So C equal to divided by multiplied by 300 divided by 25. So this is getting very less. So what mistake we are making? Oh, sorry. So here's tau divided by, yes, this is correct, R. 40.71, 300, okay. So this is given in 0.35 degree. So this is in degree. So that's why this is multiplied by pi and here multiplied by 180. So that's why multiplied by 180 divided by, this is pi. So 79971 Newton mm. This is correct now, around 80,000. So next, another relations, E equal to so I think MC divided by 2 m plus 1. So I think these relations, right? So that's why this is 1.998 into 10 to the power 5 and this is 2. So 1 divided by answers multiplied by 1.988 into 10 to the power 5 multiplied by 2. Equal to, so this is m divided by m plus 1 equal to 4.996. Now cross multiplication, m 4.996 m plus 4.996. So that's why 3.996 m so we are getting, this is minus So what will be answers? This is equal to 4.996. So that's why we are making, oh sorry, so here's this is relation is in terms of modulus of elasticity. So this is the relation. So that's why, because Poisson's ratio values that is in between 0.22, 0.25 to 0.40. So sorry, because this is the formula. Now this is 79971 and this is 1.998 into 10 to the power 5 and divided by 2 m plus 1 m plus 1 and this is 1.998. Oh sorry, so this is 79971 multiplied by 2 10 to the power 5. Seven nine nine 71 multiplied by 2 divided by 1.998 into 10 to the power 5 equal to something I did mistake. 79971 multiplied by 2 divided by 1.8 divided by 10 to the power 5. So this is equal to 0.80. So that's why m equal to 0.80 m plus 0.8. Now m equal to 0.8 or 0.2 m equal to 0.8 or 1 by m, because this is Poisson's ratio, 0.2 divided by 0.8 1/4 means this is correct. So the Poisson's ratio equal to 0.25, because Poisson's ratio 1 by m is, this is nothing but the Poisson's ratio. So this is your expected answer. So this is first problem. Now in the second problem, in a tensile test, a test piece (25 mm) in diameter, (200 mm) gauge length, is stretched 0.0975 mm under a pull of 50,000 Newton. In a torsion test, the same material or same rod twisted. Same rod means actually this is the part of the rod. So same rod, what may be the application means from that rod. Suppose this is the total length of the rods. So half portions that is used for tensile test, and remaining rod can be used for the torsion test. In a same rod twisted 0. So this is directly given, twisted 0.025 radius. In the previous problems, this is given in degree. Now this is radian over a length of 200 mm when a torque of 400 Newton meter was applied evaluate the Poisson's ratio and the 3 elastic moduli for the material. So in this problem, in the previous problems, we calculated Poisson's ratio, Young's modulus and modulus of rigidity. So in these problems, we have to calculate bulk modulus also. So means one step is more in this problems as compared to previous problem. So last problem is the first problem. Now we are familiar with the problems, so that's why for this problem I increase my speed . First, tension test. So we will use 3-page. So in the tension test, D equal to, D is the diameter 25 mm, length 200 mm. So this is the 25 mm and this is 200 mm is the length. And next, stretched delta L equal to 975 mm, P equal to 50,000 Newton. So that's why here's E equal to, so can I write P by A delta L by L's. So that's why PL divided by A into delta L. So E equal to 50,000 Newton, length equal to 200 mm, area pi by 4 d square 25 square, and this is 0.0975. E equal to 50,000 multiplied by 200 multiplied by 4 divided by pi, divided by 25 square divided by 0.0975. So this is right, 208,941 Newton mm. So that's why 2.089 10 to the power 5 per mm square. This is per mm square because this is Newton, this is length. And this is mm will get cancelled, and this is right. So next, for torsion test, same rod means diameter same rod means diameter equal to 25 mm. Theta equal to 0.25. This is directly given, radian over a length of, again length equal to 200 mm, and torque is 400 Newton meter. So that's why here's, by using relations tau divided by r, c theta divided by L, or this is equal to T divided by polar moment of inertia. So in the last problems we use this relation, now we have to use this relation. So that's why T divided by polar moment of inertia, c theta divided by L. So this is we used in the last problem. T equal to 400 Newton meters means that's why multiplied by 1000, pi by 4, this is 25 raised to 4 equal to, this is polar moment of inertia. So this is pi by 32. C, this is angle of twist 0.025 and length equal to 200, right? So C equal to 400 multiplied by 1000 into 200 multiplied by this 32 divided by pi 25 raised to 4 and 0.25. 400 multiplied by 1000 multiplied by 200 multiplied by 32 by divided by this is 83 443 Newton per mm squares. Right. So what it may be? So this is the. So after that, in the last problems we studied C equal to ME divided by 2 M plus 1. So by using this formula we can calculate the Poisson's ratio, because this Poisson's ratio we require, since this is bulk modulus K equal to ME divided by 3, this is M minus 2. So that's why we request the value of the M. So this relation means first find out M. So C equal to 83443 M E equal to 2.089 10 to the power 5 divided by 2 M plus 1. So this is M plus 1 equal to 83443 multiplied by 2 divided by 89 10 to the power 5 multiplied by 2 divided by, sorry, this is 0.79988. So again M 0.7988 M plus 0.7988. So this is 5988. Oh, 1 minus answers 0.201 M equal to 0.7988. So M equal to what? So 1 divided by answers multiplied by 79. This is 3.97. So this is 3.97 means 1 by M, that is Poisson ratio. Since K equal to, now this is put 3.97, E equal to 2.089 10 to the power 5 3.97 minus 2. So this is 3.97 into 10 to the power 5 and this is 1.97 into 2.089 into 10 to the power 5 divided by 3 divided by, so this is equal to 140,389 Newton per mm square, or K equal to 1.4 10 to the power 5. So this is correct. So for mild steel, the value of the Young's modulus, that is near about 2 into 10 to the power 5, and this modulus of rigidity C equal to 80,000, 83,000 or 84,000, and bulk modulus, this is 1.40 into 10 to the power 5 Newton per mm squares. So being as a mechanical engineer, you should know these basic values. So next problem. So this is third problem. A hollow shaft (450 mm) external diameter, external diameter and 250 mm internal diameter is subjected of 400 kilonewton meter. So this is torque. Subjected means this is torque. By using its units we can calculate this is the torque. Find the shear stresses at the outer. Find the shear stress at outer and the inner surface of the shaft. Draw shear stress distributions for the wall of the shaft. Draw shear stress distribution for the wall of shaft. Find also the twist in a length. Find also the twist in a length of 2.5 meter of the shaft. So in this case, this is external diameter and internal diameter. So first we will draw so shear stress distribution means so quarter so this is capital D and this is small d. So and distributions of the shear stress. I think this is same. No. So here's distributions of the shear stress. So this is tau max and this is tau. So capital D equal to a hollow shaft. Capital D equal to 450 small d equal to 250. T equal to 400 kilonewton meters means 400 into 10 to the power 6. So this is 10 to the power 6, this is for 10 to the power 3 per kilo and 10 to the power 3 for meter to mm. So yes, first shear stress at outer radius. So here's use tau divided by r, c theta divided by L, and this is T divided by polar moment of inertia. So we have to use this relation because this is to be calculated and this is T is given. So that's why T divided by R is equal to tau divided by, okay, and this is tau. So tau equal to, this is to be calculate max, R equal to 450 divided by, so this is 450 divided by 2, T 400 into 10 to the power 6 polar moment of inertia pi by 32, and this is capital D raised to 4. So that's why tau max, and this is 450 divided by 2 equal to 400 into 10 to the power 6 pi by 32, 450 raised to 4. So this will get cancelled, and this is 3 and this 2 and this is 16. So that's why tau max equal to, now this is 400 into 10 to the power 6 multiplied by 16, this 16 divided by pi into 450 cube, right? Into 10 to the power 6 multiplied by 16 divided by pi divided by 450 cube. Now this is equal to 22.35 mega Pascal. So this is 22.35 mega Pascal, and this is maximum. Now tau equal to, now shear stress at inner radius, tau divided by small r, again this is capital because this is the extreme and this is T divided by polar moment of inertia. So tau divided by R equal to, this is T divided by pi by 32, capital D raised to 4, small d raised to 4. So tau equal to 400 into 10 to the power 6 multiplied by radius 225, this is pi by 32, 450 raised to 4 minus 250, I think, raised to 4. Try to understand this. So this is equal to tau equal to 400 into 10 to the power 6 multiplied by 225 into 32 divided by pi into 450 raised to 4, 250 raised to 4. 400 into 10 to the power 6 multiplied by 225 multiplied by 32 divided by pi divided by 450 square minus 250 square bracket close equal to. So this is 24 point, means I am making some of the mistake. Okay, so here's this is R. So that's why this is 125. So here's divided by 250, oh sorry, 25 multiplied by 125. So this is 13.72 megapascal. And this is tau equal to 13.72 megapascal. So what is the next bit? Twist in a length of the twist in a length. So here's twist in a length means V requires modulus of rigidity. So this modulus of rigidity, right, take here's increase, take C equal to megapascal. Take C equal to 8 into 10 to the power 5. So now by using a relation, now we will use a relation so which relations we will use? T divided by polar moment of inertia, and this is C theta divided by L, because this is the torque given. So according to that we will calculate. This is 10 to the power 6 pi by 32 d raised to means 450 raised to 4, and this is 250 raised to 4 equal to C 8 into 10 to the power 4 30 theta length equal to 2.5 meters means 250. So theta equal to 400 into 10 to the power 6 multiplied by 2500 multiplied by 32. So try to understand this cross multiplication. 5 into 450 raised to 4, 250 raised to 4, 8 into 10 to the power 4. So this theta you will get in radians, and if this value multiplied by 180 divided by pi, you will get this is in degree. So that's why 400 multiplied by 10 to the power 6 into multiplied by 32 divided by pi divided by 450, sorry, bracket close, again divided by 8 divided by 10 to the power 4. So this is a radian, multiplied by 180 and divided by pi. So I am getting 0.196. 0.196 degree. So this is expected answers. So due to the limitations of the time, today I stop here and we'll continue remainings part of the torsions in the next class. Thank you.